Good morning, class. I'm Mr. Skyler. So I'll be your trainer for the topic on computational thinking. Okay, so can anyone tell me what is computational thinking? Okay. Okay. Anyone else? Okay, what is it? Yes, very good. So like what he just said, it is a problem-solving technique for you to solve problems. So any idea what are some activities that you can actually use computational thinking? Okay, project work, okay. Drawing, okay, drawing. Anything that's closely related. No? Okay, let me give you an example, see whether you can relate to it, okay? So every day after school, what is the first thing you want to do? Go home, right? Go home, go and play. Yes, correct. So now this computational thinking comes into place when you end school and then you want to find the fastest road to go home or go and play. So these will help you to think, what is the fastest route? How do I go there the fastest? Do I take bus, take MRT, or do I run there? Okay, this is where computational thinking comes into place. For now, you all will not purposely go and do it in step by step, but your brain just functions in that way. Okay, so now let me break it down into 4 different parts for you to better understand what is computational thinking. So look at this. Computational thinking actually consists of 4 steps. First, decomposition. Second, pattern recognition. Third one is called abstraction. And the fourth one is called algorithmic thinking. Okay, so let's go into the first one, decomposition. So what is decomposition? Can anyone tell me? Yes, correct. You all learned that in science, right? Break things down into smaller parts. So look at this photo. Will you all eat a whole burger in one mouth like Scooby-Doo, or will you all eat it in small mouth, like one bite, small bites? Small bites, right? Yes, that's how you break things into smaller parts. Another one, how will you memorize this string of numbers? You try. Tell me how you memorize. Okay. Okay. What about you? Okay, very good. So from both of their answer, you guys can realize that they actually break it down into smaller parts, irregardless of whether it's five numbers, and a few numbers left, or is it 3, 3, 3, 3, 1. Okay, so these are the ways you can break things down into smaller parts, and then you can solve them bit by bit. Okay, any question for decomposition? No? Okay, let's move on. Pattern recognition. Can anyone tell me what is pattern recognition? Finding similarities. Yes, finding common pattern. Correct. I believe you guys have been through this in math, where there's a pattern of different shapes, and then ask you to tell what is the next shape that's going to come out. So, like for example, it's circle, circle, square, square, circle, circle. What's the next shape? Square, square, right? Okay. So now, based on these first 6 items here, what do they have in common? What is the similarity? Hey, you can try telling me. Very good. They're all round. They're all circles. Okay. Other than this is not a circle, but it's going in a round shape also, right? Okay. So what about this? This 6 is not very direct, right? So you guys have to think, what is the similarities among these 6? Any tries? What about this? Okay, anyone else want to try? No? Okay, let me review the answer. So all of this thing starts with B. Okay, so what is this? Bone. What is this? Ball. Bowling ball. Okay, it's still B. What is this? Books. What is this? Boots. Okay, this boat. This. What is this? What is this? Ribbon. You sure ribbon starts with B? It's not in blue, so I don't think it's blue. What is this? Correct, a bow tie, a bow. Okay, so see, all these things starts with B. So this is called pattern recognition. Sometimes it's as easy as this, sometimes it's a bit more complicated. So you need to go more into details. Okay, any question on pattern recognition so far? Nope. All good? Okay, let's move on. So next is called abstraction. Abstraction is just focusing on the necessary details and taking out those that does not even matter. So for example, if we need to figure out which animal can fly, what do we need to see? Skin color, number of legs, presence of wings, or presence of a tail? Wings, right? Wings make them fly, right? Yeah, so this is abstraction, focusing on only the necessary details. Okay? Easy? Questions? No? Okay, let's move on. So the last one is called algorithmic thinking. So it is just using a sequence of steps to solve problem. So the example given here is cooking. You need to chop, you need to stir fry, then which one to put first, which one to put next, and which one to put last. These are steps for you to do before you can finish that dish. So any other examples that you can use this math, right? You need step 1, step 2, step 3, step 4 to get it right. Very good. So you see, all of you guys know what is computational thinking now. Any questions so far on the 4 parts that I just went through? Yes? No? No? All good? Okay. So from what we just went through, it consists of 4 parts. So what are the 4 parts? Very good. And the last one? Correct. Algorithmic thinking. Okay, very good. So these are the 4 parts that helps you in your computational thinking. Okay? Any questions? Anything you don't understand? Nope. All good. Okay, very good. That's all for this session. Remember, computational thinking is going to help you for your next few sessions. Okay? Thank you.